Hey, how are you guys? Welcome to this new Coffee and Crypto on this occasion again with Andres Leon, this one from the Radix today with this is lesson number 6. We were already in 6 last week. This one we released on Friday. We are there a little, but we released it on Friday, and the title was that I didn't do anything, right? This Andres was making a gumball machine, a gum vending machine that practically is. A swap is from one currency to another currency or to one inactive to something active. And today we are going to continue with that same exercise, that same example. Let's say that it is the chapter 2 of this chapter, where this gumball machine will continue to be improved to see what more things can be improved by adding. We talked a lot about how security things were added to it to see that a batch or several batches could be added so that certain people or a single person could, for example, change the price of the gum that is inside the machine. If we continue with that example, and there are many more things that can be explored, right? So welcome, Andrew. Thank you very much for your time here.
Nothing. Thanks to you, Guillermo. And we are going to continue with the explanation. These days, some people have contacted me on social networks. It's good to be grateful for that we went step by step, explaining things by stopping, but very, very, very quick explanations, and brief. And we will continue explaining. Well, today, as you said, we are going to continue with the gum vending machine the other time. Well, if you shared the screen yesterday, sorry for coughing, we still have a little cold. We were looking at, that's what we started this blueprint. We call it the gumball machine here. Oh, no, I didn't stand here. Looks good, doesn't it? Let's see. Yes, no, or I make it more, I make it bigger there, maybe bigger, a little bigger. Yes, maybe a little bigger. That's that. And what we were doing, as Guillermo mentioned, it is, for example, in the methods, finally, the last thing we did was apply a security system to them. That is, we told him, although both methods were public, we said that one was completely public and the other was public but restricted. Only the one that had the owner key that is created when instantiating this blueprint and converting it into a component within the network. Basically what we did, because what we're seeing here is create a machine, we instantiate it, we create a machine where that component creates for us, that gives us the key, so that we can then modify things as if we were the owners of the component. We create the 100 gum, in this case, in the form of a fungible token. And finally, what we did was put it all away. Within the structure of the contract itself, of the component itself. Here's the structure. What we did was save the gum, save the XRD resulting from the sale of that gum, and save the price that we established. Once we instantiated the component, and then we created another. Well, we created a method where what we did was sell the gum, we just got the XRDs. We would take the exact price of the gum, we would put it in our permanent vault, within the component in the XRDs of the exact price. And what we would do was return the gum to the person and the turns. If he had sent us more XRD than the price of the gum, then we would return the rounds as we traditionally do physically, and finally establish a method by which we could change at any time. Once the component is instantiated with this function, we could change the price of the gum. And all we do is put the price of the gum on the call, the new price of the gum. And what we did was, modify one. One variable for another, the self-refers, is referring to the structure, the price. And what we did was change the type of price. And as we have said to this one, we had defined this one in such a way that only the one who presented as an insignia that we have created here, which is the owner's, only that here he will present that insignia. Could he set that change? Okay, but of course, who's missing things? What are we going to do today, for example? Today we are going to, among other things, we are going to establish, well, a method to be able to extract the XRDs, okay? Because people are buying us, okay? And now I want to collect that profit. We are going to create that. We are going to create a method to refill the gum machine, a refill of the machine, in such a way that whenever we see that they are being spent, we leave the machine again at 100 gum, excuse me. And finally, we are going to see, well, finally, among other things, we are also going to see how to extract specific information using a custom type, a custom structure, a custom data type, so that we can see how that is also done. And, well, and then we continue, but let's start, come on. First, it would be how to extract, right? Let's do it first. Let's think about what it is. How would you like how would we want the method to be? We created a public method, okay? Although you are already thinking that if we want to extract it, only the owner can extract it again, okay? And that's what we're going to do now. But we have said methods always have to be public unless we want them to only be able to access it within the component. In this case, we want to access this method from outside the component, from our wallet. Okay, that's why it's public, but we'll put a restriction on it later. Okay, and we could call this perfectly. Well, that withdraw tells me that he suggests collecting XRD. Well, it could be perfectly. We are going to do it as the example says, because that way people follow the example. Earnings means not or profits, okay? And he's already suggesting something to us. Okay, this is what I have here. The Copilot, I think I have installed here, or Super Maven. Well, I have one of the two installed artificial intelligences that help you with autocompletes, okay? I also have, as you know, I also have the Mira extension activated. You see, it is asking me here to restart the extension. I have the Yes one. I have the Copilot here. I have the Radix extension and the Rust analyzer. Okay, so we had it the other day. We didn't have it activated. Well, earnings doesn't tell me anything now. Ah, yes. Well, let's just accept it. What are you telling me? Well, it's immediately filling me with the what precisely makes it a method. That is, it allows us to access the entire component with the self from this method. And we also include the moot, because it's in case we want to change something within the self, okay? And this is what we are going to do when we want to extract its tokens from a variable. We are changing that variable, and that is why we are mutating its content. Okay, so this is perfect. And finally, what they are going to return to me is a bouquet fungible. Okay, I mean, in the end, what are XRDS is going to return to me? What are XRDs if not a fungible? Okay, well, a bouquet fungible inside a temporary container. And here he is already telling me, look, he has told me perfectly, because this is Colette. XRD wasn't what we were keeping inside this permanent container called Connect XRD. That's where we were saving it, because he says self-connect XRD. That is, we refer to the component, the name of the component, and that we take old, because he knows that take old, because if we stop, we will realize that one of the traits he has is take all. Okay, we can do a take and say exactly the ones we want to extract, but look, it gives us the take all. The thing is that it is very simple to say anything and return us a bucket of the type of container, since it is returning us a fungible bucket, the take all. And for this to return to us, what we do is that we do not put it behind. Okay, well, with this, we would already have we pull everything out of the Colette XRD container. Now, what we would have to do here would be to put, as we did the other day, the restriction. Well, then I keep the name, this I copy, okay? And what I do is put it here, okay? And I do exactly the same thing as with this. Okay, I put a restriction on you. I tell you that only. Can the owner access this method? Okay, and with this, we would have already done the method to extract them at any time. The XRDs that we had as gain within the component are worth it. Very easy, right? Simple.
Well, lag towards, that is, I would do it towards the wallet that is connected.
Yeah, that's it. The one towards whom you are clearly calling the difference with others we were saying the other day, the difference with other types of DLT programming environments, especially if we are talking about Ethereum virtual machine environments, which is not only Ethereum, but there are many chains that are using the Ethereum virtual machine and Solidity. The thing is that in those systems, it is always necessary to tell him who it is. Do you want to know who the person, who the wallet is calling and where the wallet goes? Okay, because they work forever in line with the wallets. Of course, what that does is that it closes you the number of possibilities you have to do things, especially in this case to create blueprints, that is plans where we can later implement. Or do we want to allow anyone to implement it? No. So we have to make it as open as possible. And then the radio people said, well, look, we're going to remove the restriction of knowing which wallet it is or which wallet it has to go to. If not, what we're going to do is that it's actually always going to be returned to the wallet that's asking me, okay, at least in what the contracts are, the components are worth, so I don't care what wallet it is. If I want to know if he has permission or not, I'm not going to read the wallet. That happens in contracts with Solidity. You have a whitelist or blacklist, in this case, a whitelist of wallets that they could access. Okay, so only the owner of that wallet could access certain functions. We can do it in Solidity, which, let's just say, does not make it as versatile as the fact of having one as we have created, a badge, as if it were a kind of key. In this case, it is with a fungible token where I can have it in my wallet and I present it as proof that I have it, or if I want you to be the one to do it, well, I can give it to you and you can present it as proof, but I don't have to give you my wallet, because if I give you my wallet, I already know the private key of my wallet. You realize the insecurity that could be there. Okay, but if I just give you the token, in that way, no, we are not violating any type of security. Only by owning the token can you access these two methods, the set price and extracting the profits from them makes it much more versatile. You know, it is more Radix allows you. We will see it more. Surely the next lesson. We will only talk about the transaction manifest Radix allows you. For example, imagine that I am the boss and you are the person who is going to manage the money. Worth, the one who is finally going to take it where it goes, is going to keep it or whatever. We can execute a transaction where I, who I am the boss, present the proof, but you are the one who carries it in your wallet. The money, you know, then, in that case, two completely different people with their own wallets. What happens is that you do not have the ability to access this method. Yes, in the same transaction, I can present the key so that you allow yourself to now take the result of it. That this thing I'm saying is so extremely versatile. It's okay that other networks are unable to do so right now. Yes, I did.
It is something that we had talked about previously, not that something could be done that, for example, to buy a plane ticket, you had said the example, you can wait for two wallets to connect and make the transaction, something like that.
Indeed, it is similar. It is similar, would be similar in this way. The idea is that the architecture that has implemented Radix with an asset-oriented method, what it basically allows is, let's say, do things that on other networks we couldn't do. Okay? Was it very difficult to get? Basically because it is very focused on assets, expendable and non-expendable. Okay, he's created a whole environment around them that allows us as programmers in a simple way to be able to move them around and be able to play with them at will. Okay, what about this whole badge system? That what they allow you to do is detach yourself from the accounts and basically center yourself. Is it okay to look? In the end, Guillermo knows what happens, unless it happens to me, huh? That when I think about models, contract models or whatever, it is much easier for me with this formula, with the asset-oriented paradigm, to think about truly decentralized applications. Because he meditates. All this, I am telling you, prevents me from creating centralized backend systems, which is what happens now in many applications, that although they have smart contracts, then the backend has to manage it properly. There are things in the backend and you have to handle it completely centrally. Veil and Radix in this case allows you to do really more decentralized things. Well, let's move on. Let's refill the Gumball machine, okay? We are going to fill it out. For that, we are going to do another method, okay? UFM refill Gumball is okay machine. And she is telling me refill. Notice that she already knows. Come on. Okay, this one is okay for me, although we are going to do something else. Well, just as it is a method, we put the self-mutable. Because we are going to modify something of the veil component. And now we're going to tell him as if we had to introduce him from the outside. He's setting an example for us. He is telling us that from the outside, we are going to introduce a bucket with chewing gum. Okay? And that what he is then not saying is that we are simply going to fill these chewing gum inside our permanent chewing gum container, but we are not going to do it like that. It's fine what you said with pilot, but we're not going to do it like this. Basically, because we don't have gum outside, that's what he knows. Okay? So this forgives us. We're not going to do it like this. We're going to remove this. In this case, it is not going to give us anything back. That is not why we do not put this, because it does not give us anything back, is what you're saying, okay? But let's do something else. For example, the first thing we have said before is that we are going to imagine that this machine only allows you to have inside, that is, it has a limit of gumballs, okay? Of gum, since like a real machine, it does not have a container. And we're only going to let 100 in. In fact, if you remember, we created it with 100, okay? And then we're only going to let up to 100 in. So the first thing we should know is how many gunballs are left in the container, okay? We can do that by calling the self gunball, okay? And again, it is telling me that put, not put, but amount. Look, we have 111 features, which is an amount, okay? Which allows us to do that because it will give us back. This tells us, well, it would tell us exactly the amount of chewing gum that we have left inside the Gumball's container that we have here is the one that keeps the chewing gum that remains in the value component. Well, if we know the gum there is, well, this would be easy. We would declare a variable that would be, for example, Gumball amount is okay. It is equal to what at 100, that what I want to have less is worth less, those that already exist. So here, always in Gumball amount, I will have the amount I need to fill it completely. Okay, do we get it? No. If we have 80 minus 100, then it's going to give me 20 here. If I have 100, it's going to give me 0. Okay, you don't need to fill it in. And once we have it filled in, that is, once we have the amount here, okay, What we have to do is create them because we don't have them. No, we don't have those we don't have those gumballs. We have to create it, not for it. To do this, we would have to cheat them or allow them to be cheated when we registered the Gumball, which was here in the instance when we instantiated the Gumball. When we instantiate the forgive component, we create the Gumballs. And with a supply of 100, it's okay. But if you realize here in theory, we don't see any place where it tells us that we can cheat or how we can cheat these Gumballs. Okay, because we now need to modify this a little to be able to do it. From there, we have to give him access to Minteo. What we do here is we initially minted 100. Okay, that's what we're seeing here. To do this, what we are going to do is create Minteo roles. Okay, we have that here. Okay, min roles. Okay, and these min roles. Okay, what it's going to allow us is define who can lie and who can't lie. Okay, the syntax is like this. Okay, period. Okay, because this all comes from here. Okay, period divisibility. Metadata. Min, well, mind roles. Okay, who can means. Okay, as we saw the other day. Okay, we can define very complex roles. To specify who or who can do something. We didn't do it down here with the owner, if you remember. We made a rule, a role, okay, where we said that only the one who owned the badge was the owner of this component. No, well, here it is similar. Here what we are telling you is who, that is what role it is. The one who will be able to mint, and for this we can establish two different roles. The minter is worth the minter. Oh, sorry, the minter. Wow, the minter. Okay, and it auto-completes me. You didn't tell me completely minter oysters? Stay still, the minter is worth it. Well, we're going to finish establishing it. Okay, it would be the minter. Okay, it would be, well, as we have done other times with con. Let's say with the equal, and the little script is like making a kind of arrow. Okay, and we would tell you who can do it. And here, what Radix has done is that he has established some keywords that we can use because we define the rule just like we did last time. We define the rule, okay, with the mo. And here in parentheses, okay, we can say, let's see. They have established the parentheses in parentheses. We can tell low. Outlow, all hollow, all veil. How many parentheses has he put into tal, hollow, all that is? Hey, okay, yes, okay, it doesn't give me any more. It doesn't give me any errors in all that's if it's giving me the errors again. No, I don't know what error it's giving me. Because look, the other one doesn't tell me that I'm missing the other one. The inter updater is. So we have two different roles, the minter and the minter updater. Okay? And the same story. Okay, we copy it. Okay, what happens here at inter or inter, I'm going to use the other one, that we have the other keyword that we have, which is Veni. Okay, now yes, he no longer complains, it's not worth it, and YY in any type of this, we will see later. Okay, when we create a token, whether fungible or non-fungible, we can do all those actions that we can do with a token. That is, ventilate them, burn them, move them from one place to another, etc. Give two roles. On the one hand, the action itself, is that I have a dry throat. And then who can update that action? That is the role that the person who has the ability to use the minter updater role can change this rule from here you see it as I have, that no one is authorized. What I am expressly saying is that no one can change this rule. Okay, so this one here, imagine that we put the owner here, okay? Imagine that here, we told him that this here requires, we could do it. Okay, we could, they are one this here. The rule is the same. The rule that we told him is from here. Okay? Who could update it? Who could update the all load and maybe put it on denying everyone changing it? Only the owner. Well, let's leave it like that, okay? Let's leave it like that. Whatever happens, I wanted you to see that the other keyword that was denied to everyone, okay? That's normal? No, normally you deny everyone, okay? But so you can see that we can do other types of stories, okay? Here right now, what we're telling you is that this token, the GUM token, okay, everyone's going to be able to cheat it, and no one's going to be able to update the rule that everyone can cheat. In other words, this rule is going to stay like this forever. Okay, so when we've established him, we've already established him. Let's say the rules for minting. Now we can mint it now from here. What we can do is directly mint it. And it is as easy as telling themselves, of course, here we would have to know the resource manager, and we don't have it. Okay, wait 1 second. We don't have this right here to be able to cheat it. I need to know the gumballs. I need to know the result. We have the resource builder, which is the one that allows us to build the token. And then we have the resource manager, which is the one that allows us to modify or manage. The token that we have built is worth it, and we don't have it right now. We haven't saved it. We would have to specify it here. We are going to save it within the component to be able to use it later. Okay? Then we'd have to keep it here. Resource manager, values, Y is a fungible resource. Here's manager. So is what we're going to keep inside the structure worth it? Let's see. Let them give us no error. Here is giving us an error now. Because there are no methods. Because we have included 2 methods. And no, we corrected that now. Okay, here what we are saving within the structure, okay, is the, let's say, the address is okay, or what is going to allow us to uniquely identify. Okay, to this resource manager, to Gumball resource manager, and now having it here. Now, yes, well, I could have copied it, right? This here now, yes, I could have copied it. Now I come here, okay, where we were in the refill, and I say self period. I refer to the Gumball resource manager, and now, yes, here it allows me to do many things. Look, it allows me, for example, to burn. Minting, knowing the address, obviously cloning it. Well, doing allows us to do many things. It's worth changing. For example, we could, if we had permission, we could change the minting rule, for example, which we have now said that everyone was denied. We could change it there too. But now you are interested in minting how many the NU tells us we have to put in it. How many do we want? Minter, well, what we have before. What we have calculated before is not the Gumball amount. The Gumball amount is what we are going to use here to know how many we want to mint. And this, the result here is worth the, given this from here, for example, we could have told him, let Gumball is the same, it is the same as this. And now we could tell you now what the artificial intelligence told us, that now it is not remembering here again, the self Gumball, that is the container. We are going to put all the Gumballs that we have already minted.
Oh,
Okay, we can do this so it looks very good, or we could even do it directly. So it could also be good. Okay, this here would also be valid. It's with, as is, because we don't give anything back. Okay, it's directly here, we would put the other thing. For me, even if it's more lines of code, I like it better this way. I think it's much clearer. You know what we're doing? Worth every one on your line to me. So we repeat, we calculate how many gumballs are left up to 100. Once, what we have calculated and what we do is that we mine. To mine, we need the resource manager. Let's remember, we had resource builder that allows us to create the resource manager token. It allows us to manage the token, okay? But in order to know exactly what resource I want to handle, I need to save it, okay? I need to save that information. And finally, what I do is I put it into the container where I keep the gum. I put the gum that I just minted, okay? And now above what you're telling me, here I need to establish this method, and obviously it is telling me restriction 2. Okay, let's just say that only the owner is worth it. He is the one who will be able to refill the gum machine. Well, with this, we would also have the filling ready. Now I would like, well, some questions. Do you have any questions, William?
Kong.
Okay, now I'd like to touch a little on the subject of creating our own types. If you remember the other day in the explanation we made with that drawing, we said that before the method here, we can create, that is before that of the module, forgive before the module, here we will be able to create our own types. Normally we can create, for example, we're going to create either enumerators or structures, well, or any other type we want. Okay? Here, for example, let's create a structure. Okay? We're going to make it public, a structure that's similar to this here. Here we actually create a structure. Okay. A structure is a data type within Rust. It allows us to group different types of data in a single site, and we can also give those different types of data a name that clearly identifies them. Is that worth it then? Well, we create 111 structure, and here, this structure, we are going to tell you that it has public price. That is of decimal type, and which is also price, the amount is worth, and which is of the decimal type, okay? And here what I am going to do is that it is a comma. Well, we would have created the structure, but of course, when we are using data types, he is already telling me here, look how smart Copilot is. We have to tell him what it would be like to serialize and deserialize the data type, okay? That's important. That is how it handles this type of data when it is transmitting it between the different packets, components, etc. In this case, within the module. That's why Radix has made us something similar to this, okay? But instead of using these are the Rust's own, okay? Instead, use Rust's own methods. What he has done is that he has created written that bore, which is the serialization system of serialization. For structures, you have to give them a name. I was missing the name for the structures inside. And why are you giving me this? Failed script, now yes, no, now it's okay. I'm missing one UP, that's okay. So we can sterilize and deserialize thanks to this tool that it gives us. script, okay? He is putting it here for us. Because of the prelude, he is putting it for us when loading the bookstore. Okay, and this is going to allow the smart contract to be valid. In this case, the blueprint can use this new type that we have created. I explain this to you here now because when we see the creation of NFTs, when we create one NFT, and we would have to create a data type to hold data within the FT. We're going to do it this way, okay? We're going to do it the same way. And now here, we could create a new method, a new public method that would somehow allow us to know get. Look, he's giving it to me. Look, that's it. I think it's okay. How smart is it, eh? Get status. Okay, get status. Where in this case, since we are not going to notice this, gives us reason to explain one thing to you. Here you have realized that it doesn't tell us about the mute. You have seen that it doesn't say here about the mute. Why doesn't it say about the mute? Because in this case, I'm not going to modify. No data type inside the component.
Just the...
I'm reading, so I don't have to modify it. So these are some of the things that Rust has that makes it so powerful in the sense that it's so fast and so versatile. The fact that he monitors a lot, he monitors means that we do not use resources that are not necessary. I declare a variable to modify it. I use more memory than when I declare it read only. So he's interested. Rust, the compiler, is interested in us not wasting our system resources, and so it allows us to do certain things. In this case, it tells us, look, it's not just because you're not going to modify absolutely anything. Look here, what we are going to return so far. If you remember, we've only returned expendable buckets, non-expendable buckets, etc. Okay, whoops, this one. Here is that something is missing. Here there is an error. Now we will see. Now we see the error that is okay. But here we are telling you that we are going to return a type of data. What type of data? Type of data. Status. The data that we have declared here. Status type data is valid. And now I have to create the status data. Okay, I open the keys. And what I do is I say price and amount. And price what I do. I read the price that I have established here in the component structure. I have established the price, and I read this we have already used before. I read the amount of gum left in the container, and with that, I establish the amount. And with that, we would be returning information from within the contract type, so that we can use it later when we read the information. It's okay to return data, not return structured data, so that it is a much more modern methodology than simply returning a series of data. Okay? Here we have an error. This is him telling us an error, and I already know what it is. He's telling us we're missing something. Look what he's telling you. Look. He's telling you, hey, missing gum resource manager friend, we're missing the gum resource manager. I have put it here, but I have not declared it. That is, I have not filled it out below. When we do the self, when instantiating the component, if you remember. Inside the self, I have to tell him the gumballs, the XR, the price, and I have to pass this on to him. What is this? Well, here he is telling me, I don't know what. No, it's not that. This is this. The bucket of gambles, okay? The one we have created is okay with the resource builder. Okay, I got it here. And now I sure have a resource. Look, I have it here. Resource manager. This returns me the address. Let's call it that. The address of the resource manager, so I can save it. Here we are going to see if we save, and here it gives us another error. Okay, but this other error here is very good. What error is it giving us here? If you look, here it is telling us, hey, be careful, borrow the borrowing. Borrowing. If there is one thing to learn in Rust, it is the topic of loans. Okay? And whose properties are they? Whose is something worth? If you remember everyone's first day, I explained that one of the advantages that Rust has over other types of programming languages, and what makes it so fast and so efficient, and that's why many companies are using it for everything, well, like this, things that are behind it, etc. That is system applications. I mean, it handles memory very efficiently. It is so efficient at managing memory that it does not need garbage collection systems that other programming languages do. Okay, he's able to remove the garbage collectors because he forces you to use your memory correctly. We've seen it before with the unchangeable. Okay, and now we're going to see it with the issue of who owns something. It doesn't leave you in any other programming language or many programming languages. What we've done here wouldn't pose any kind of problem. Okay, and here he is telling me that be careful, that the property has already been moved. That already. Excuse me for saying this LED, this bucket of Gumball's variable, when at this point in the processing program, it no longer exists in the instance. It is no longer here in the instance, within this function, already in this. And you say, and where has it gone here? Here it has disappeared here, the moment we use it here. It disappeared, died, left for what? Because it became a bucket. Look what we have done here. We converted it from a bucket to a bound. It disappeared, it burned it, but this doesn't do scripting, this does Rust, okay? So how would we solve this? Look how I'm going to solve it. I've moved the line. You're missing a comma, huh? Have you seen it being resolved already? Why did I fix this? Because at this point in the process, bucket of Gumballs still exists, and its validity is crucial. But who is the owner, or where is he living? Does he still live within the function? Actually, I haven't taken her anywhere. I have only asked him to tell me a resource manager property, okay? And when he goes to the next line, that is when he disappears. Because what I just happened here now. Okay, this is one thing that, what is, let's say, understanding it or seeing how it works and being able to solve many times the conflicts that we encounter with loans, with properties, is the most difficult thing that Rust or K has, right?
You can spend hours and hours trying to solve something that's simple, can't you?
Normally, it's due to the architecture or design of the application being flawed. Bad for Rust? I mean, maybe in JavaScript, it would work perfectly for you, but in Rust, it doesn't work because it forces you to be very meticulous with the variables. It works, and the life of the life cycle of a variable. So for example, if we go back to this here and I move it down here, it gives us the error again. Well, a simple way that many people do is point. I think I don't know if clone will serve me. And it already gives me an error here because I can't clone. I can't clone a voucher. It won't let me clone a one of these, okay? But that in many cases would have worked. The clone works, that is, if we are talking about a variable, which in this case is that there is a restriction because a bucket type, I can't clone it, okay? It won't let me clone it. The type is defined. So that it is not clonable, Obviously, it could not clone buckets because then it would be duplicating the assets that are inside it. Okay? And that's why it's defined like that. But in other types of variables in Rust, which are not, let's say, do not transport assets, you clone it, and let's say that somehow what you do is you don't use it. Are you creating a copy? And it is what you use at that moment. And then you are not killing the variable that comes by. I mean that it is a mess. What the clone thing is a mess. But that many people, when you start working in a Rust, they tell you point clone, everything is calm, and you will learn how to use it. Okay? But look here, it's so easy. I'm telling you, it's as easy as moving it up, and that's it. That's it, because this one doesn't take it away, and here it disappears, and no one complains anymore. Okay? We'd have it. This one complains because I lack status. Come on, let's take the status. Which is status? Okay, we go here, and this is as a status. We can make it perfectly public. I would say no. It is simply to get information. We saved it, and we would have it there in public. Well, we have already learned some. It has given us the opportunity to learn a few more things about Rust, okay? And we will continue to see examples, and we will continue to see how to do it little by little. Let's not go crazy either. Why? Because we will continue to see many more examples of how it is done. Okay? Well, what do you say we leave it here? Okay? And the next day we will arrange ourselves and we will do it. We are going to do a complete review of the transaction manifests to create all the manifests for this OK component. That's going to be the next day.
All right, perfect.
A lot, isn't it?
But I say that it looks easy right now that I'm seeing it, and you make everything logical to me when you're doing it.
That's it. That's it. That's it. That's it. But you've seen that Copilot tells me a lot of things.
But
yeah, he does, and that's free, huh? I'm not paying for this Copilot. Let's see. Let him not know. Copilot is Microsoft's artificial intelligence for programming. Okay, and then Copilot. I have Copilot because I have the GitHub account, Veil, and GitHub. GitHub gives you Copilot. It is a very soft version. It is very, very soft. But for self-filling, for what it is suggesting, it is perfect.
Absolutely, yes. I've recommended numerous excellent things.
Indeed. I think I could inquire about things here. For example, look, my scope tells me, here you're seeing it. Yes, it doesn't tell me to use the current file, and I could tell him, can you document this code for me in Spanish? Let's see what he does. There he goes. Look, he's telling me. Have you seen him? Come on, change it for me. It is generating it. Oh no, I said that I told him to regenerate it.
What?
Regenerate it, don't you? This is this one that edit with Copilot. This is edit. I use another one and I tell one of these buttons and it changes it automatically. But hey, here it is giving me one is giving me what we have done. Well, not everything. No.
No, you don't see everything.
You can't see only parts, Bah. What a mess. Now, I don't like it, well, but you have to have a free compilot, you know. For example, we could have said, above all, when you have some error, you know, it's going great. You say the code, and it says, give me any suggestions to fix this error, you know. Let's see if I did it. That is, if I'm here with this, I'll take it here. This isn't too challenging. Anyway, correcting this error isn't hard, right? You can fix it and see the effect, he says. It certainly refers to the code here. Well, no, but no.
Kong.
You've changed it, haven't you? Well, it's not that good. Well, there's nothing much I can recommend. I'm sorry, folks. It's not that good. And that's why it's free, right? But for a filled car, if you've seen that it functions, we would leave this chat. So how do I remove this now? I don't use it at all.
If you have an itch, go to where the chat is on the left. The top left looks like a little orange. If it stings, don't press it. Don't alert it.
I don't know how to explore such. I don't know what this is. At some point in these, you can surely get edits. No, I don't know. Well, I already have it.
Found the
chat, but
Kong.
Yes, it's here, but it doesn't take me away. It's the chat. It doesn't take me away. It says, hide secondary. Oh, okay, that's it. There it is, okay? Yes, I like to handle it, and I like to handle it here with the B, which is the one I usually use the most. You know, this one here, and like that, it's cleaner, and not everything is better. Well, that's it. Copilot, that you have already seen that Copilot is free, because it quickly allows you, it does autocomplete for you. And since it is seeing you, it's not that Copilot knows script. That's what I was going to do. It's not that Copilot knows script, what happens, but since it is seeing you, the code that you are doing. Okay, well, then he more or less senses where the matter is going. And Russ, if he does know in theory, Rad knows, okay, you've seen that he's more or less doing it.
Okay, it's absolutely perfect. Thank you so much, Andres, for this comprehensive lesson number 6. We're eagerly anticipating lesson number 7. Don't forget to do your exercises and verify that everything Andres has taught us is progressing correctly so we can keep up. All right then, see you next week. Thank you very much, Andres. Good night there and good afternoon here. Looking forward to seeing you in the next lesson.
Come on, thank you, William.